a technical webinar, Building a Aircraft Career, the Saga of Grit and Technical Transformations, which is organized by the institution in support of the Institution of Innovative Industrial Engineering and Entrepreneurs, Mumbai, and Maharashtra State Center of Institution of Engineers. So, I welcome to all the eminent and distinguished speakers and the moderators. First, I welcome to our Honorable President of Institution of Engineers, Dr. Hemant Thakre, who will preside and guide this technical webinar. And this technical webinar is possible only to organize the dynamic and the eminent in the field of Commander Dr. Bhandarkar sir. I welcome to the Cartel Chairman of the Institution of Engineers, Dr. G. Ranganathan. I welcome to distinguished faculty member, Rear Admiral G.K. Harish, Aviation, and the former Director General, Naval Design of the Surface Ship Group. I welcome to Commander Karthikeyan Subramaniam, former CMD and Cochin Shipyard Limited, Cochin, and the distinguished moderator, Commander Jitendra Vyasham, IN retired, former CMD of the CSL. I welcome to our webinar conductor and presenter, Commander Prasad Padhe. He is the Project Director of Marine Engineering Division, Shipbuilding. I welcome to our Institution of Engineering, Maharashtra State General Secretary, Sri V.C. Kamble sir. So, this glorious history of India's aircraft careers, one of the single fine quote has made our Honorable Prime Minister. Vikrant is not just a warship. This is a testament to the hard work, talent, influence, and commitment of the India's in the 21st century. If the goals are distant, the journeys are long, the ocean and challenges are endless, then India's answer is Ikram. The incomparable Amrit of Azadi Ka Amrit Mahotsav is the Vikrant. So, in this field of the Naval Marine Division, our eminent speaker, distinguished moderator, and addressee, they will come to know what is the importance of the glorious history of India's aircraft career. And further, I hand over to our presenter, Commander Prasad Padhe. Commander Prasad Padhe is a marine engineer with a service of steam and diesels. During his 24-year service, he has served from largest to smallest warship of the Navy. He faced fires, flooding, and was awarded a Chief Naval Staff Commendation for damage control on an aircraft carrier. His short tenure have been seen him involved with the training the new generation of mariners. He has been responsible for the space and store supply for the Indian as well as a Qatari Emir Navy, handled resources and facilities management and QA as per the entire supply management chain. He is built warship for the Coast Guard at Mumbai and Goa. So I welcome once again to Prasad Padhe, and he will continue to the further webinar program. Thank you.
Thank you, Dr. Godbole. Ladies and gentlemen, a small brief about the person who's just briefed us right now. Dr. K.M. Godbole is the chairman of the Navi Mumbai Local Center and the chief engineer of CIDCO Mumbai. However, a lot more needs to be said about him. To begin with, he is not just a civil engineer, but he's a postgraduate MTech from NIT Surathkal. After this, the engineer in him decided to be a graduate in law. So you have an LLB also. And thereafter, we also had Mr. Godbole thereafter being introduced to us as Dr. Godbole, who's done his doctorate in technology. He has been working in the City Industrial Development Corporation of Maharashtra, that is CIDCO, since 1989. And he's worked in various positions, right from assistant executive engineer, and he's presently in the position of chief engineer, Navi Mumbai. So we really have an eminent person who's there as our chairman, sir. As far as his work profile is concerned, he's been associated with the various infrastructure works for Navi Mumbai City, Navi Mumbai railway station projects that have been completed. The present projects are Navi Mumbai Metro Lines 1, 2, 3, and 4, and mass housing projects under the Prime Minister's Awas Yojana. He also has been looking as a water transport project, Nerul Jetty, and allied city development works. We are honored to have him as a person. And for me, sir, it's an honor to have been introduced by you. For me to take this topic slightly ahead and to speak about it, well, the reason why Commander Bhandarkar very specifically called me is because I am ex-INS Vikrant. I must tell you that this is, of course, the old INS Vikrant, which was commissioned in 1961 and which was decommissioned in 1997. It is the legacy of that which I carry, and it was on this aircraft carrier that I got my Chief of Naval Staff commendation. To begin with, Vikrant, as far as the Indian Navy is concerned, is not just a ship. A ship is not just made of the bulkheads and the deckheads. The ship is always made of the men who man her. And what a phenomenal crew we had in Vikrant. And the best part is a person coming to Vikrant imbibes those same values of grit and determination on board the aircraft carrier. To give a short history of the old Vikrant, Romeo 11, as I may call it, first and foremost, she came physically to India on the 15th of November, 1961. And ladies and gentlemen, because I'm in Goa, let me tell you, she was immediately used in the Goa operations, wherein she was the main fleet around which the entire Goa operations took place. Yes, INS Betwa was very much there. Yes, the other ships were very much there, but it was because of the presence of Vikrant. 1 month into coming into Indian waters, she was having gushed duty outside of Goa, and it is then that the liberation of Goa could take place on the 19th of December, 1961. The same fighting spirit has been carried on by the aircraft carrier in the 1971 war, wherein the cities of Chittagaon, Khulna, Cox's Bazar were attacked. And besides that, the multiple airstrikes that took place on Changla, Mongla, and all across the entire delta of the Padma River as we know it. What it means, what an aircraft carrier means, gentlemen, is denial of the sea, whether it is off Goa for the Portuguese Navy, whether it is in the Bay of Bengal for not only the Pakistani Navy, but the Pakistani Army as well as the Pakistani Air Force also. Throughout this time, one of the most important things to keep in mind as far as INS Vikrant was concerned was that with 4 boilers, the ship was built. It was on the basis of 3 boilers that the ship has carried out its entire 1971 mission of Bangla liberation. So it is this grit and determination which has been carried through. I also was witness on the 2nd of September to witness the historic commissioning of IAC, INS Vikrant, which of course we'll be hearing about very soon. So ladies and gentlemen, it is not just a ship, it is an emotion. And more importantly, just exactly like the Honorable Prime Minister has said, it is Azadi Ka Amrit Mahotsav. Vikrant Virat hai, Vikrant Vishal hai. These were the words which our Honorable Prime Minister used. And it is not just about the ship, but the entire change in the thought process that takes place in getting a ship from a blueprint into reality, in getting a ship from the first cut of the keel right up to the final sea trials and the final power trials, for which we have a galaxy of people who will be explaining what has been their role. So, ladies and gentlemen, may we sit back and enjoy the ride as we get an input into the fantastic art of building a new aircraft carrier building a thought process for the Navy and building an entire nation based on technology. To take you further, ladies and gentlemen, I will now request an address by the chairman of MRDB, Commander Dr. Bhaskar Bhandarkar. Commander Bhandarkar, sir.
Honorable Commodore Jitendran, sir, the visionary who has devoted decades of quality life to promoting excellence in shipbuilding and naval architecture. Rear Admiral Harish, the accomplished officer and distinguished naval architect of the global repute, who is the brain behind design of INS Vikrant. Commodore Karthik Subramaniam, the acclaimed mariner and the former chairman and managing director, Cochin Shipyard Limited. Dr. K.M. Godbole, the chief engineer from SIDCO, who is nourishing the dream of world-class infrastructure and civic amenities at Navi Mumbai. Engineer V.C. Kamble, the dynamic secretary of Maharashtra State Center and former chairman of Navi Mumbai Local Center, whose quality case is ushering new dimension of excellence in the metro projects of MRDA. Commander Prasad Pagde, the young and adorable project director from Marmar Engineering Building. Council member Dr. Sadhan Ray, MRDB member Sri Bindu Mohanji, distinguished members of Institution of Marine Engineers and Institution of Engineers, participants, friends from media, dear students, and our enterprising and hardworking staff from Technical Division of Institution of Engineers, Headquarters, Kolkata, ladies and gentlemen. It gives me immense pleasure to extend my best wishes to all the participants of this webinar related to the honor and pride associated with Atmanirbhar Bharat. India has a glorious history of maritime heritage. The earliest reference goes to Veda, Rig Veda. The beginning of India's maritime history dates back to 3000 before Christ. During this time, the inhabitants of Indus Valley civilization had maritime trade links with Mesopotamia. Indian mythology has numerous episodes pertaining to the ocean, the sea, and rivers, with belief that mankind has benefited from wealth of seas and ocean. Indian subcontinent exercised supremacy over Indian Ocean from very early times up to the 30th century. The Cholas, Cheras, and Pandyas were major power of peninsular India. These rulers had established strong maritime trade links with the local rulers of Sumatra, Java, Malay Peninsula, Thailand, and China. With the invasion of foreign power, the Indian industries, including the maritime industries, were driven to the backstage. Once again, India is surging ahead. The indigenous design and building of aircraft carrier is the testimony to this. Aircraft carrier is called as a moving township. Most of the branches of engineering and technology are involved in shipbuilding of aircraft carrier. However, it's by no means it is a simple job. A simple welding needs a very high level of skills and the knowledge of metallurgy and metals. It is a technical marvel and a saga of great and technological transformations. Marine Engineering Division Board, Institution of Engineers, in its effort to promote excellence in the maritime domain, has facilitated the availability of distinguished international personalities with huge experience and technical knowledge to share their vision on these important issues. I am confident that the participants will be immensely benefited from these deliberations. I wish all of you a great take-home content. Thank you. Shano Varuna, Jai Hind, Jai Institution of Engineers.
Thank you, sir. That was Commodore Bhaskar Bhandarkar. We now move on to the address by our chairman, Dr. G. Ranganath, who's chairman, CATE Engineers. Dr. Ranganathan, sir.
No, he's not there.
He's not there. We have
There is a problem, network problem.
Dr. H.O. Thackeray, sir.
No, he's not there.
In which case, ladies and gentlemen, let us move on. And it gives me great pleasure to introduce the moderator, Commodore Jitendran, who is a Vishishta Seva Medal and who's retired from the Indian Navy. A small brief about Commodore Jitendran. He's retired as the chairman and managing director of Cochin Shipyard Limited. He has been commissioned in the engineering branch of the Navy in December of 1972 and specialized as a naval architect. He's held various designations and he was in charge of the design of the prestigious aircraft carrier project since 1988. After permanent absorption in 2002 as Director Operations of Cochin Shipyard, he retired as CMD of CSL after a 5-year tenure from May 05 to May 2010. Commodore Jitendran has a postgraduate specialization in naval architecture and was a fellow member of the prestigious Royal Institute of Naval Architects, London. During his tenure of over 8 years in Cochin Shipyard, he laid the foundation for detailed design and building of the IAC, that is the Indian Aircraft Carrier. Simultaneously, more than 35, I say it again, 35 and the US, bringing the yard to a Mini Ratna Category 1 status and the best performing and diversified shipyard in India even to date. A record of launching 5 ships for different owners on one day. This was set on the 2nd of June 2008 for the first time in India, and it stands till date. Commodore Jitendran's unique achievement has been being the team leader of the country's first indigenous aircraft carrier design, which he successfully steered through the difficult initial stages of design in the Navy and subsequent manufacture in Cochin Shipyard and brought it close to the launching stage. He brought several laurels and awards to Cochin Shipyard as a torchbearer for Indian shipbuilding capability. Ladies and gentlemen, I now present to you Commodore M. Jitendran, Vishishta Seva Medal of the Indian Navy. So,
good evening, all of you. Thank you very much, Commander Prasad, for the introduction. The Vikrant project actually has steered to a large extent my entire life and that of my family in a big way. Right from the time I was a junior commander, approximately in end of 80s, till the time I retired from Cochin Shipyard in 2010-11, this project was the center of everything that was happening in this project. There was even several years of doing nothing, which happened initially, until we were able to come to a stage where the basic design was accepted by the naval planners as the most and the best futuristic option to be built in India. And it was approved by the then government in place. I had several interactions during this period with the government, then defense ministers, and because the presentations were made and all the difficult questions used to be asked, whether we can really make this, whether this is really some kind of a dream that you guys are going to waste money and so many things, And we had, for every person who was willing to bat for the project or willing to say, yes, this can be done in India, there were at least 100 people who used to tell, no, this is not possible, this is a waste of time. And the worst part was we had a lot of foreigners, including from, the British and the other, who had given us their aircraft carriers earlier, who used to come and tell our various staff and others that, look, this is beyond your capacity, this is beyond your planning abilities, this is beyond so many, ways of tripping and, or, diverting the sheer, will and determination that was required to see this project through. But still it happened. And I am very happy that, there were, even at that time, people who believed in our design capability, who believed in our ability to project a strategy, to build ability to actually convert that shipyard. We had selected the largest shipyard. Of course, Harish will cover more on the design. Selected the largest shipyard because this was going to be the largest ship ever built in India of that size, and capability. So it was a saga which lasted from 1988, and I am very happy that during this period, I was able to leave behind not only the Navy, very good people like Harish, who was taken over later on, and then Subbu, who was with me as director, and actually both of us used to take rounds of that ship many times together. And then I was very happy to hand over to him and go, and he continued and launched the ship actually a little later after I left, because there were issues at that time. And then, of course, he had left behind a very good team himself. And then there was a fabulous finish, which you have all seen recently. Indeed, the spirit of Vikrant that was definitely, imbibed into the new ship in a many different ways, including the workers of the shipyard, the various other people there was a sense of pride. There was a sense, all the initial misgivings were, rubbed off, and slowly, suddenly, as it was taking shape, the eyes started opening, and oh, wow, this is really being done. And okay, let's do a little more and push it forward. And like that, from virtually a blank piece of paper, I was very happy, and I keep telling my many people whom I meet, I'm going to die a very happy man, because I started with a blank piece of paper. I'm very happy to leave it with Subbu, with almost, all the blocks in place, and he had, of course, to launch it later. And of course, we had people like Harish, who were in the last mile connectivity is always an issue, and design comes in very, very critical, because he has to actually prove that the design parameters have been achieved and accept the ship on behalf of the Navy from the design and performance angle. And these were the issues that he has done very commendably. And in the process, something fantastic has been achieved. Our design bureau, where we were, my days, we started with small boats, and my first project was a frigate, but it went bigger and bigger and bigger. And today he has made sure that it has become a warship design bureau. So with that, I will stop here for the seminar to continue, and over to my panelists to give the nitty-gritty of what actually it was all about. So do I have to, shall I introduce Admiral Harish now? Is that the next part of the program?
Please do, sir. You're the moderator.
Yes.
Okay. Admiral Harish is a very distinguished and accomplished naval architect who has spent more than 35 years in the Navy, and has the crowning glory of having retired as the senior most naval architect, the Director General of Naval Design, which it coincided with the delivery of INS Vikrant as well. I mean, it's a fabulous journey, I would say, as a career. Though he joined as a civil engineer, he obtained 2 postgraduate qualifications from IIT Delhi and IIT Kharagpur in naval architecture and ocean engineering. And during his career, he held several appointments, both in the dockyards and in the other support organizations in fleet. But in between, he spent several years in the Directorate of Naval Design in Delhi, almost 18 of those, half of his career, in different capacities. He worked on ASW corvettes, he has worked on frigates, he has worked on destroyers, and therefore definitely, the right man to do the last mile connectivity of Vikrant. So his glorious contributions, as I mentioned earlier, has resulted in the Directorate of Naval Design today becoming an independent warship design bureau, in keeping with some of the best in the world. And I'm very proud that now I belong to that kind of, I belong one day to that kind of place. He was awarded by the President of India a Vishishta Seva Medal and a Vishishta Seva Medal for his devotion and fantastic contribution to naval design. So over to Harish for your talk.
Thank you very much, sir. I hope I'm visible and audible. Commodore Jitendran, sir, moderator of the session, and a very distinguished panelist along with me, Commodore Karthik Subramanian. I'm caught I am sandwiched between 2 great witty people, and that's a pleasure for me to speak today. Happy morning to all young participants of this seminar. It's indeed very endearing to get an opportunity to share my thoughts with you. I start my presentation with your permission, sir.
Yeah, please.
So, gentlemen, Indigenous aircraft carrier Vikrant is a historical milestone in naval shipbuilding. And I must say, start with a disclaimer that I have been very humble and a small cog in the big wheel, which many people over the years have turned in order to get this fabulous achievement for our nation. The scope of the presentation, it is important to get the macro picture and context right, because we have young participants. So I will bring in why warships are different from other platforms, combat platforms, the history, a small history of how we have reached, the role and working of an aircraft carrier, important design criterion, challenges in aircraft carrier design, and way ahead on naval shipbuilding as a full gambit is important for us to take us forward to the next level. So this is, the idea is aircraft carrier is a very complex subject, so it will be challenging to present it in 35 minutes, but I will be touching only on macro level issues so that you get a basic flavor of what the whole issue is all about. So if you look at aircrafts and tanks, we'll find that they are platforms which are designed first, their prototypes are developed, they are fully tested, and the supply chain for each and every component on the product is very clearly known before you start assembly line mass production. So the uncertainties which are there in a prototype construction are very limited. In comparison, the warships are system of systems. They are built in low quantities of with high unit cost, comprise of millions of piece parts. There are no prototype, and the long gestation period world over for realization brings in obsolescence challenges. So if we look at a typical volume dependent design, the picture depicts you have got the air element, you've got the land element, and you've got the sea element, all to be housed in a single ship. So this presents a unique challenge for the designer to get the trade-offs balanced to get a design which is functional and performing. So I thought it'd be interesting for people which are, I'm sure Institution of Engineers has students belonging to different spectrum of and different disciplines. So all of you can contribute to ship design and construction and have been contributing. So I just wanted to to connect with you through this picture, showing that each one of you contributes to nation building. If we look at warship acquisitions, the weapon-intensive platforms are designed by the Navy in order to reduce the uncertainties which come with, as Commodore Jitendran mentioned, there are performance liability issues, and therefore weapon-intensive platforms are designed by the Navy. But simpler platforms where weapon intensity are less, they are built they are designed and built by the shipyard. So that includes the functional design and the detailed design. The division in case of weapon intensive platform is that the Navy does the functional design and is responsible for the performance liability, whereas the detailed design is done by the shipyards. So if you see the history and genesis of Indian Navy's design organization from 1960s to today, it is the unique naval vision for Make in India for almost 40 years that has brought us to this stage. And in 1986, a separate submarine design group was carved out. This is a spectrum of ships that have been designed and delivered by the Navy. Often it is said that naval shipbuilding is a drain on economy. So it is important to correct this misconception, because the naval shipbuilding is a direct and indirectly contributes to growth of the Indian economy. In fact, by a KPMG study, the multiplier factor is roughly about 6.4 in the ancillary industries. It also leads to technology and infrastructure development, equipment indigenization. In fact, this is where the transformation comes from. And besides this, there is a plowback earnings to state in terms of taxes, duties, and dividends. So naval shipbuilding is an economic multiplier and not a drain on the economy. So if you look at the number of ongoing programs, total about 38, 36 of the ships which are on order are being constructed within the country, which is a huge signpost for all of us. And there are 33 ships on anvil and about 36 ships and submarines on planning stage. So this crystallization or realization of combat platforms comes with involvement of large number of diverse stakeholders who need to be intermeshed and aligned towards a common goal of achieving a combat platform. So this is, of course, very challenging, and this is also gives us a lot of strength we can draw on the experience and expertise of so many people in different organizations. So Make in India story thus far, 19 designs to which more than 90 ships have been built. Now let us come to the main topic, that is role and working of an aircraft carrier. So if we see the definition, often in simplistic terms, if I were to say, all of us have seen airports, and an aircraft carrier is much different from a land-based airport, because this airbase is a floating airbase, which has capabilities for carrying aircrafts, arming aircrafts, deploying and recovery of aircrafts. And it is self-sufficient. It has ammunition and fuel complex within it, and it can work in heavy seas and winds. So it has the capability for sea denial and sea control, and operates with a carrier battle group. And basic operational leverage you get away from the shores where the Air Force fighters have endurance issues. So this helps us in sea denial and sea control. So a small video to illustrate how an aircraft carrier functions, so that you are clearly able to understand. This is the aircraft taking off from the ski jump. A panoramic view of the aircraft carrier. Landing of a helicopter. Helicopters can land vertically on a carrier. Now we see the view from the side. You can see the island superstructure, the lifts, the ski jump, parked aircraft, bridge, and the flyco, which control the aircraft functioning and navigation of the ship. A closer view of the bridge and the flag bridge. We can see the flyco from where you have a full view of the flight deck, which helps in control of landing on takeoff of carriers, aircrafts. The view of the hangar where aircrafts are stored for maintenance and other work. So you can see the aircraft being moved inside the hangar, which is below the flight deck. Hangar is roughly the size of 2 Olympic size swimming pools. That's just to give you an idea. And the flight deck, this is a turntable. We see the aircraft moving onto the lift. The deck edge lift connects the hangar to the flight deck. You see the aircraft taking off from ski jump. Aircraft landing with being captured by the arrestor wires to reduce its speed so that it can land on shorter length. Here again, you can see so we have seen how an aircraft carrier functions. Now, just to give you and revise what we have learned, this is the landing part where from the aircraft gets launched to aircraft lifts. You can see this is the island superstructure, which houses the bridge from everything, where everything is controlled. This is the landing area, and there's a parking area where the aircrafts are positioned. Now we see a plan view. So in aircraft carriers, you have an angle deck. This is the landing part, and this is a takeoff part, and they are at an angle which allows simultaneous landing and takeoff take place. In combat, this is of great relevance. Now we'll come to the important design criteria for aircraft carriers. The main payload of an aircraft carrier is the aircraft. So everything has to be tailored around what the aircraft needs. So what are the types of aircraft? There'll be fighter aircraft, there'll be helicopters, there'll be early warning aircrafts, and they need to be housed on the carrier. What are the types? What is the wind on deck is a very important criteria, because you must understand that the wind blows against the ship, and with the relative wind, you get lift for the aircraft. So if the wind is or the speed is not sufficient of the carrier, then it becomes difficult to land and take off aircrafts. So that concept is very important to understand. You have launch and recovery systems, which I'll cover in greater detail. You need to provide services to the aircraft. There is a flight deck and hangar configuration, which determines the total number of aircrafts you can carry. And sortie generation rate in combat, it's very important that how fast you can launch and recover aircrafts. And endurance of a carrier, since it is operating far from the shore, you need larger endurance so that you don't have to refuel from tankers or you don't have to turn around. So these are the MiG-29K fighters. This is what is used on Vikramaditya and Vikrant. Light combat aircraft, which HAL has designed. It's already landed on VKD or Vikramaditya. It will land soon on Vikrant as well. This is the ALH, the helicopter, and unmanned air vehicle, which is being in the development process. So if you see here, you will see large number of aircrafts listed, and you will find the red boxes indicate the maximum parameters. So if you include the length, the beam, and the height and weight of different aircrafts, you will find that the size of the carrier increases. And the challenge that we have is how to keep the size of the carrier as minimal as possible with as diverse aircrafts as possible, and in order to keep the costs low. Because we are a developing nation with competing priorities. So naturally, we cannot build very super carriers, big super carriers. So helicopters, similarly, you can see that the design drivers come from a overlapping of dimensions of different helicopters. Now we come to the important part, that the recovery and launch blocks need to be integrated. And the angle needs to be determined with, computational fluid dynamic studies in order to determine what is the best, the alignment of these two runways, so that the aircrafts, their operations can be maximized. Now let's look at different types of launch and recovery configurations. So this is a typical short takeoff ski jump, where the aircrafts get a vectored thrust, and that gives you an advantage to take off with higher all-up weight of the aircraft. Then the Sea Harriers were there, which could vertically land and take off. And these were the configuration used on old Vikrant and Virat. Now, Vikramaditya and new Vikrant use a different concept. The takeoff is similar to the earlier part. It is from a ski jump, but the aircrafts are not able to land vertically, and therefore they are landing as normal aircrafts land, and their speed is reduced because we have a shorter length for them to land by use of arrestor wires. You can see the wires on the deck here, and there is a tow hook which clamps onto this wire to arrest the aircraft. The next version is the catapult takeoff but arrested recovery, where the all-up weight of the aircrafts are larger. It is like something we used to use gulel, if you remember, or a boomerang, where it is launched with a thrust. So the catapult is more like it throws with a force, so that even with from a shorter runway with larger all-up weight, the aircrafts can be launched. The recovery is similar to what I described earlier. The advanced ones are the electromagnetic launch system, aircraft launch system, which is developed by the US Navy for USS Ford. That is their latest aircraft carrier. And then there is an advanced arrestor gear, which is basically a water turbine in order to reduce the speed of the aircraft. So these two advancements help in higher sortie generation rate. They are suited for larger number of aircrafts, heavier aircrafts, provides better safety and reliability. So besides affording lower manning and maintenance. Services which are catered by for an aircraft on a carrier. This is just an illustration. So you will have to cater for power, aviation fuel, oxygen, which is used in the aviation suit and in the cockpit for the safety of the pilot. Nitrogen, which is, makes the safety of the aviation fuel, which is saved, stored on the aircraft. Inertial navigation settings are so that the aircraft and the ship are looking at the same target. There is a need for, recalibration every time the aircraft lands and takes off from a carrier. Now, what are the challenges in aircraft carrier design? So basically the presentation says, or the theme of the seminar is technical transformation. So I have tried to list down, in my opinion, what are the big technical transformation drivers, the scale which Commodore Jitendran mentioned, integration complexity of integrating so many aircrafts to land and take off. The aviation facility complex itself was hugely challenging for an aircraft which is not designed within the country and from outside. So we needed help from the Russians to do that and achieve commonality with VKD. Then the equipment ecosystem, most of the equipment, 76% had to be sourced indigenously. About 100 MSMEs were involved with Cochin Shipyard in sourcing small things. So you had to work with them, and Navy has succeeded because of its involvement. We have never treated our industry partners, the industry as partners. We have not treated them as contractors. So there is a closer relationship, and this has led to big buildup of human skill sets, both in the shipyard, design office, and even in the ancillary industry. So this is the largest project for IN and CSL, and the whole thing is challenging because of limited legacy data. Because with the legacy data, you get good experience and good judgment to, for decision making during execution of the project. So if you were to just compare the scale part, if you were to define more, if you see the displacement, power, AC capacity, etc., it's almost 5 times. So when you're building a frigate or a destroyer, you have to multiply everything by 5, and so it brings in a lot of challenges in execution of the program. So as I said, primary payload was MiG-29K, commonality change. Then while the ship was getting built, we had experience earlier of Vikrant and Virat. Then we got experience of Vikramaditya, which brought in a lot of changes. So it was quite challenging how to accommodate those changes during building of the project. There were equipment delivery issues. The systems, like for example, the HVAC design is based on heat load of all equipment. So unless you order and you get the L1 make of the equipment, you're not sure of the heat load. And therefore the HVAC design, it sort of evolves as the ship is getting built. So this brings in large number of uncertainties and getting all the fittings in time, getting the systems buttoned up. Therefore, the realization of Vikrant with unforeseen uncertainties required collective grit and determination of the shipyard and the design organization and all team members in this endeavor. So I always give this example like a jigsaw puzzle. All of us have played the jigsaw puzzle. So we know that the pieces of a jigsaw puzzle need to be shaped and sized correctly in order for them to fit up properly and make a good picture. Therefore, ship design requires a good balance between various requirements. And here, the priority has to be assigned for aircraft operation. So if you see a typical illustration of which are the volume guzzlers on a typical carrier, of course, the big hangar, the big machinery room, which you see here, accommodation for almost about 1,000, 5,000 or 1,000 to 2,000 people, and the island superstructure where all the sensors and all come. So the magazines for the aircrafts and for the ship. So design and construction requires integrative approach. So this is where the main skill set development has taken place. You have to do physical integration, then you have to do functional integration, and then of course software integration to make sure that everybody is looking in the same direction. Always it's a problem that how do you fit in the elephant in a smaller volume. Also, it is important that the aircraft carrier must perform well, and therefore we must cater good power margins in the initial stages, because the displacement tends to grow up because estimates are always very challenging. Whether it is budget estimate for the country or weight estimates for the ship, the estimates are challenging. And here we are estimating over a 10-year period where budget estimates are only for 1 year. The ship motions are also very critical for aircraft operations. So there is a lot of churning on what should be the acceptance norms and how to make sure that the platform that we build is useful. I'm just presenting one design trade-off study just to give an example. If you see this is the island superstructure, and here is the flyco. So the design of this island superstructure requires a clear view. There are a large number of sensors on top, which requires good EMI, EMC, electromagnetic interference, and that control. Intakes and uptakes for the gas turbine, which are always used, also pass through this area. So this was a very complex, how to get all the people to fit into this small place. We can't make this bigger because then it will interfere with the landing and takeoff of the aircrafts. And we don't want the exhaust to flow in such a direction that they obliterate the pilot's view. So these are design trade-offs. Then you can always go for a single island or double island. This is Queen Elizabeth carrier of the UK. And this is Nimitz of the US Navy, where you see the footprint is smaller. Here the footprint has been divided. So basically you decouple the requirements. So this whole island superstructure design was studied in computational fluid dynamics to make sure that the results are accurate. Similarly, we use a lot of finite element techniques for design of the structure of the ship. Now, another important factor, which is that unless the building blocks are good, you can't optimize the size of a ship. So the equipment that you have is very important, and how mature is your vendor base is very critical. So if you look at float, move and fight, we still have a lot of indigenization to be done. Always there is a thought process that we should indigenize everything. In my opinion, indigenizing everything when the number of carriers are less may not be the right option. This is my view, because if the numbers are less, it does not make a business case for the industry. However, wherever there is technology denial, where there is dual use to generate volumes, mass production can be done of high volume items or high value, low volume items, then it makes a case. So we need to filter every case that we are indigenizing through these filters to make sure that it is a sustainable option in long term. Way ahead on naval shipbuilding. So the question that automatically comes is, Vikrant, what next? And we need to build on confidence that we have gained from building of Vikrant to make a unmanned teaming carrier in future, where both not just manned aircrafts, but even unmanned aerial vehicles can operate from the same platform. This is the thought process for the future. We need to make sure that the design studies are undertaken prior to the acceptance of necessity. That one can save us time, because right now what happens is the design studies take place only after the acceptance of necessities, and therefore the design process get pushed into the construction timelines. So this is something which has been debated, and I'm sure it will come through in future. So we need to also augment infrastructure and water depths to build ships faster, because there are dredging issues which come up. Because as the carrier gets built up, you need dredging quite frequently. The future carrier will also have a twin-engine deck-based fighter, which is being developed by HAL, and we expect the development to take place by 2026. So this is something which will be the prime payload, and if it can be developed in the country, it will be fantastic for the shipbuilding community as well as the aerospace community. We need to preserve our skill sets, so more carriers need to be built, and we need to, this whole business of Atmanirbharta, in my view, is a game of volumes. Unless we are able to get the game of volumes and have smaller number of vendors, their sustenance in future will be quite challenging. Now, once we have talked about the aircraft carrier, we must look at the macro picture where shipbuilding is, because aircraft carrier is one platform. There are a large number of destroyers, frigates that we are building. How can we get our ecosystem to go to the next level? So I coined a term called, we want the shipbuilding to live longer. So we need to plan, L stands for plan long term. I stands for creating institutions. V stands for generating volumes, and E stands for nurturing excellence as we move forward. So there are worries of the industry from we have high taxation rates, and even the interest on working capital are quite high. So what happens is there is a cost differential about 15 to 20%, which makes our case very difficult. So it is very important that we look at these issues to move things forward. We need disruptive policy changes, not incremental changes, to make a big difference. Shipbuilding needs to be treated as a strategic infra industry as it is done in Korea, China, and Japan. Why? Because it's a huge employment generator. That is where the social leverage is there for us to push this agenda. We need a legislation and empower institutions, because the industry needs consistent policies, and consistent policies come from laws. So numbers cannot only come from INS, Coast Guard. We need to build the shipbuilding critical mass by building commercial ships in India. Unless we are competitive in commercial shipbuilding, most of our foreign trade takes place on foreign built vessels or second-hand vessels taken from abroad, which money needs to be plowed back into the country. That's my view. Of course, green ships, digital twin, they are the technologies of the future. So I've written a small paper with young students who would like to, they can go on VIF and Google and get a copy of this paper to get a comprehensive idea on shipbuilding. So with I come to the end of my presentation. With our collective grit and determination, we have overcome many challenges towards realizing Vikrant, our national dream. And that this is brought in rare technical transformation. India now is a part of elite group of nations capable of designing and building its own aircraft carriers. So in my opinion, together we can do what seems truly challenging. Thank you very much for your patient hearing.
Thank you, Harish. That was very informative, and I must say to the audience, to understand what went. I mean, just to give you a perspective, even when we started the design of the carrier, we were still using log tables and not a slide rule, but normal adding and counting machines. There was no computer when we started. Of course, it started coming slowly. We even built up the computer centers in Directorate of Naval Design, and by that time it got I would say by the time Subbu was there, well, we had the latest going, and we had almost 600 people under training, even including those we were exporting manpower who were trained on computers from Cochin Shipyard for some time, because that was the only way we could get people in to learn this design process, especially the detail engineering, make the whole thing in 3D. And I must thank Harish for bringing out the real perspective, the start, the difference between naval shipbuilding and war, and the challenges that are involved technically, the number of stakeholders, the need to actually convince a lot of people that this is something, because it's a compromise exercise. It's not something, you can just do a set of equations and you have the answer. So thanks a lot, Harit, for your talk, which is covered. We will take, I will moderate a little more after the next panelist completes his part of this thing, and allow me to introduce my good friend Commodore Karthik Subramaniam. He's a mechanical engineer, but became a outstanding marine engineer after joining the Navy, where he served on various types of ships as a marine engineer, from missile boats to large destroyers. He was also part of the commissioning crew of a naval tanker. So there you are. He has not only the warship, but also the merchant ship. Well, the naval tanker is really not a merchant ship, but something like that. His career, which was very illustrious, I must say, included appointments in the dockyards as well, both Eastern and Western, as well as in naval headquarters. In naval headquarters, we served together for some time in the same directorate, though he was working on a big destroyer project at that time. He has a postgraduate degree from Madras University in Defense Studies. After his tenure in Navy, he joined me in Cochin Shipyard. When I became chairman, he came in as number 2, and I gave him the aircraft carrier project as the thing which has to be his bread and butter, almost, I must say, in Cochin Shipyard, which I must say I am very happy that he took on from their block building stage and brought the ship to launch, and launched it in 2013, I think, and left behind a team. And that's what is the most important in Cochin Shipyard, a team which was capable, which was well-trained, which had all the skill sets, which a shipyard which was initially labeled as not capable of doing a thing like this because they were a merchant shipyard. So on, all these theories were belied, and finally, a fabulous fancy ship has come out of the shipyard. I am very happy of the developments that took place. So over to you, Subbu, and let's hear your presentation.
Thank you, sir. I hope I am audible. First, I'd like to thank the Institution of Engineers for giving me this opportunity to share my experiences in building this wonderful ship. In particular, I'd like to thank Bhaskar Bhandarkar, who reached out to me and invited me to be on this panel. First, of course, I'd like to thank Commodore Jitendran. Our association, like he said, goes back a long way. I mean, we started off in Vizag dockyard at somewhere in 1985-86, and it's been over 36 years that we've been together. He's been more than just a friend. He's been a mentor. He's been a guide while in the Navy. And thereafter, he chose me to be his deputy in shipyard, and finally left as the CMD, and I took over from him. Just to tell you briefly that if there's some person who's most qualified to talk about the aircraft carrier and its building, I think it is Commodore Jitendran. It's his baby, actually. He started from the concept design, got the sanction, got it to a point where the government has said yes, and after having got that, he came to Cochin Shipyard and started building the ship. So in effect, today, if you're seeing this aircraft carrier, the person who's to be thanked, or rather the person who's actually behind the entire aircraft carrier, I think is Commodore Jitendran. I think he's done an enormous service to the Navy and to the nation. in getting the aircraft carrier sanctioned and, of course, starting the building. Before I begin and share my presentation, of course, the small caveat, I left the shipyard 6 years ago. So my information that I'm going to put out is a little dated in the sense, but essentially it will capture what challenges we faced, what are the issues that we had, and what is the complexity. And of course, Harish has already touched upon it, but I will try and give you a flavor of what it is to build an aircraft carrier. So with that, let me just share my screen. Yeah, I hope you can see this. I hope you can see can you see the presentation?
Yeah, it's okay.
Okay. So there you see the aircraft carrier in all its glory, majestic carrier. Now, this carrier is actually a synergetic effort between the Indian Navy and Cochin Shipyard. The design is completely indigenous. It's been done by the Director of Naval Design, now called the Warship Design Bureau, which two stalwarts are there, Commodore Jitendran and Admiral Harish. The detailed engineering construction, including procurement of all material, equipment, and systems, was done by the shipyard. So we did the detailed engineering after getting the basic design from the Navy. This is a build strategy that we adopted is called concurrent design and ship construction, which is that while the design was being developed, we also started building the aircraft carrier. As a shipbuilder, and I think Commodore Jitendran will bear me out, this is not something that a shipbuilder is very happy with. He'd like the design to be frozen and given to him and told, get on with the work. But warships are a little different. We've been building warships like this, and the aircraft carrier was no different. So we had to adopt a strategy where we were given part of the design, we started working on it while the design evolved. We had some issues with this, and I will touch upon it briefly, why this is not a very comfortable thing for a shipbuilder. In terms of the size, Harish has already talked about it. If you see the scale and size in terms of, whether it's the displacement, in terms of steel weight, in terms of the power, it's just not comparable. It's about 6 to 7 times that of a comparable destroyer or frigate in terms of the complexity, it's even more. So this is something which we had to contend with. Okay, so we'll come to the challenges that we faced quickly. As I said, it was the project of a size and scale and complexity not undertaken earlier in the country. The first challenge we had was a non-availability of Russian steel. The shipyard, the aircraft was designed to be built with Russian steel, but due to a set of reasons, we couldn't get the steel from Russia, and we had to develop this ourselves. And I will tell you what happened, how the Indian industry, the DRDO and the Indian industry, came into reckoning, how they actually stood up, and we were able to continue building the aircraft carrier. Evolving design, I mentioned this earlier, integration of new systems. The aircraft carrier is actually it's actually a system of systems. There are a huge number of systems. They all have to be integrated. So that poses challenges in itself. The management of the supply chain, both the indigenous vendors and business partners, as well as foreign vendors. And of course, we had a huge challenge because we were dependent on the Russians for the aviation facilities complex, essentially because the aircraft which is going to take off from the aircraft carrier is Russian, which is the MiG-29. Okay. the steel for the aircraft carrier was cut in 2003, but we had to suspend construction because we couldn't get the Russian steel. The steel was developed by a DRDO lab, Defense Metallurgical Research Laboratory, Hyderabad, and it was productionized by SAIL. In fact, 3 plants, Bokaro, Bhilai, and Rourkela, all 3 were involved. And because of the various grades of size, they've developed 2 types of steel, one for the hull, which is DMR 249 Alpha, and one for the flight deck, which is 249 Bravo. And these were in different thicknesses. So these were productionized by SAIL. On the shipyard side, we had to develop new weld procedures because there's a high tensile steel. And I'm happy to say that the shipyard did develop these procedures. And incidentally, today, all the ships in the Indian Navy, I understand, are built using the same steel. So in terms of our self-reliance on steel, today, the Indian Navy is using only indigenous steel. We are not dependent on any foreign supplier for steel. Now, we had to develop various weld procedures, which we did. And because of the schedule, though it might, we had to actually use a lot of automation. I have a few pictures of the automation that we did. So I'll show you about some of the pictures that we have. And also the technical challenges of welding huge fabricated structures at the A bracket and P bracket. That is, the brackets through which the shafting is installed. Okay. So we'll talk about the grit and innovation to overcome the challenges which we faced during the construction of the aircraft carrier. Now, the first thing is, while we developed the steel, we also had issues getting the bulb bars. These are, members that are used in the frame. And so we had to fabricate a lot of these things. And we said, how do we fabricate such large numbers? So actually, this was developed in-house by the shipyard. And it was done by, a team within the shipyard. We didn't go out anywhere. We gave them the problem and the shipyard came up with the solution. And we've done a lot of this using submerged arc welding. We automated the entire process so that we could increase the throughput and the quality that the Navy wanted. Because shipyards typically, the warship building, warships are built to a different standards. We build commercial ships to commercial standards. The warships are built to mill standards, which are much more exacting. So this was done. This is just automation of the fillet weld of an IIC block. And then we curved blocks. We had to do a lot of this automation. You can see it here again. You find that it was an innovative thing. They just got things together. We made a railing. We put this welding machine on that and automated it and turned the block around. So there was, downheld welding so that your quality is assured. Shafting is again something that we had to do. 2 shafts, one of 60 meters and the other 100 meters. Now you can imagine a 100-meter length is actually something like the size of a football field. You have to insert a shaft through the hull and it goes 100 meters. Now you have A and P brackets which are more than 100 tons. Now how do you put this under the hull where you have an overhang? You can't use a crane. So you got to figure out, make fixtures, jigs and fixtures where it will support a weight of 100, 105 tons and be able to actually position this in the right position. So it's actually very challenging, but again, this is, what we had to do. You see the P bracket and A bracket, they were actually they were fabricated and supplied as 2 arms were supplied separately and the boss was supplied separately. So we had to develop a welding procedure, ensure there's no distortion. And the size of this is 335 millimeters. That's more than a foot thick, right? But this welding procedure was developed in-house. We had young engineers. Joseph did a great job. Here you see this is the structure that I was talking about. You see, this is the bracket. This is 104 tons, right? And you can't use a crane. You got to have a fixture which can move in all three directions. You have to align this, because after you align this, the shaft goes through this. It's very intricate. Your tolerances are all in terms of millimeters or less than millimeters. And you have to align the shaft so that you don't have vibrations and the shaft can operate smoothly. So you have to develop a jig. This was developed in-house. So this is where, the transformation, or shall we say the application, the commitment of the yard. And, this is all done by the shipyard workers within Cochin Shipyard. So this is a great job that they did. Another view of this is where, it could move back and forth. It could go up and down, move sideways. So all three motions you could control and align the shaft goes through this boss. So you could align it, and this is done in-house. I told you about the shaft, 100 meters long. Now, how do you support and install the shaft through all the bushes in the ship? So we developed this trolley. We put this shaft on the trolley. Again, this trolley can be moved in all three directions. It can go up and down, back and forth, sideways. So you can actually align it in a manner in which you can insert the shaft. So this was done. This helped. This entire development was done by shipyard. There was a retired supervisor whom we enlisted, and he came up with this innovative trolley. So the picture of, finally after the fitment of the rudder and the propellers, this is just a shot we took. So this was done by, using all these gadgets that I talked about. Okay. Now, why a shipbuilder is not very comfortable with this evolving design is just one example. We actually finalized, the procurement of a DA, a diesel alternator, which powers the ship. But the Navy, and it was done in September 2007, the moment I joined the shipyard in August, and we were ready to place the order. But we were told by the Navy, hang on, I think we need to do something again. So based on the feedback, and, we are not, this is what happens when you have a design which is developing. You're learning from your other ships. You're learning from, what could happen in future. So it's an evolving design. So they found that based on the feedback from Vikramaditya, you have to increase the capacity of the generator. So we had to put this procurement on hold and start afresh. Now this had consequences. So this is something that happens, and like Harish mentioned about the HVAC, the heating, air conditioning, ventilation system, in terms of positioning of equipment, the heat load calculations, the freezing of compartments, all of this get affected in case, you find that your design is not fully frozen. So this is something that we had to contend with, but I'm happy to say that we've overcome all of it, and we were able to incorporate whatever the Navy wanted. Now, this is about the installation of the ski jump and the pontoon assisted launch. What happened was, the shipyard has a limitation. The building dock, you could launch a ship with a draft limitation of 5 meters. So when we conceived the launching plan, this is how the ship was to be. It was just, you can see just a steel structure. And I went to the Chief of Naval Staff and I told him, sir, we are ready to launch the ship, and you please, tell us whom you want to call as your chief guest. And, we will make all the arrangements. Typically, the launching is shipyard function. So I went to the Chief of Naval Staff, Admiral Joshi, and I told him, we are ready to launch. Please tell us the date. So he told me, during the briefing, I told him this is what it be. So he said, okay, Subbu, you can go and launch, but the Navy will not have any part of this. We will not be part of the launching ceremony. We will not participate. So I was taken aback. I said, how can I launch? He said, no, this doesn't look like an aircraft carrier. Defining feature of an aircraft carrier, at least this aircraft carrier, is a ski jump. And if you don't have the ski jump, I'm not coming for the launching. I'm not allowing it to be launched. So now this was what he wanted. He wanted this structure to be incorporated. You're all engineers, so you can just imagine this. This is about 2,500 tons. Now you have to put this at this end, at one end of the ship. You can just imagine the sort of moment it will create, the weight it will have, both in terms of what effect it will have on the draft, what effect it will have on list and the trim. So I said, this is very difficult. So I came back a little. I was actually very, very worried. I came back to the shipyard. I called my project manager, Vijay Bhaskar, and I told him, see, we have to get this done, right? You have to put this, otherwise the ship is not getting launched. The Navy is not allowing the ship to be launched. So two young naval architects, Sanup and one of the boy, Hari Krishnan, they said, sir, leave this problem and we'll come back to you. So about a week later, they came back and they said, sir, we will put buoyancy pontoons. Now, this is a steel structure which is, fitted beneath the ship. And so I went back to the DG&D, who was my boss, and I told him, this is the solution we have. We will put buoyancy pontoons and we'll launch the ship. Now, again, Cochin Shipyard was building a warship for the first time. Cochin Shipyard was actually only building merchant vessels. So this was the first warship we were building, and we were building the aircraft carrier. So he said, yeah, do you know the type of risks that you're taking? I said, yeah, don't worry. We have fixed the problem. We have a solution. We've got this vetted by the IRS and it will work. Trust me. So he was very, very apprehensive. He said, are you sure? I said, don't worry. So I asked my team, Vijay and these two boys came. He said, sir, don't worry. We've got it all taped up. It will work. Do you trust us? That is the only question they had. I said, yes, I do. You just go ahead and you will have no problem. And this is exactly what happened. And when she was launched, she was looking like this. Picture perfect launch. The trim was 300 millimeters as designed, and there was absolutely no problem. So this was something that I'll carry, throughout my life. This is a problem that was thrown up at the shipyard. But again, it was the team that sat down, worked on it. And this is where we talk about grit. You don't give up. We got to say, it's not possible, it's either this or that. But the Chief of Naval Staff wanted this, and we did it. So it gave me a lot of pleasure. It is something that I will cherish for the rest of my life, because this is a real life problem that we tackled. Technical challenges, we had challenges in every aspect of shipbuilding. Cabling, other ships have 400, max 500 meters of cabling, kilometers. We had something like 2,000 kilometers, 4 times as much. So we had to develop a software, and these cables were not of the same size. Normal ships, they're 1.5 megawatt of power, and you have 440 volts. Here you have a generator of 3 megawatt, 440 volts. Currents are very high. The cable sizes are much, much larger. So it was a challenge to start pulling the cables. In terms of the amount of cables to be laid, typically, you do about 6, 7, maybe, at best about 10 kilometers of cable laying. Here, the shipyard did about 100 kilometers. So it was something which was fascinating in terms of size. Then the IPMS. This is something that is again, new to the shipyard. This ship has various systems. It's got a propulsion system, auxiliary machineries, damage control, health monitoring, onboard training, power generation, various, domestic systems. All of them are integrated and it's managed by this IPMS. You can actually, it's an integrated platform management system. You can sense, you can control. So it's a versatile system, and this was given to BHEL, and they, in a partnership with Avio, Italy, have developed this. And when I went back last time, I asked the boy, Anish, who was working on this, he said, sir, all of it is working. So that is, testimony to the skill and commitment of the shipyard. Then the aviation facilities complex, this was actually very, very, very challenging because we had one vendor, which is the Russian, and this entire thing was designed to, operate the MiG-29K, but we had a lot of issues. So actually, this was started by Commodore Jitendran. We said, let's go and see if we can get from, other sources, which we did. So, and it was a good thing that we've got, actually we found that some of these things are over-designed for the MiG-29, but now that will come in useful because now, like what Harish mentioned, you got the twin engine deck fighter aircraft that is being developed by the DRDO. The naval version of the LCA perhaps will be developed. So these things now will come in useful, and we'll probably be able to fly off other aircrafts other than just the MiG. In fact, I think the Navy is now looking at Super Hornets and also Rafale M for flying off the aircraft carrier. So the basin trials were completed in November 2020, and the propulsion, power generation, shafting, steering gear, they were all proved in the first sea sortie. What was very reassuring and very, very satisfying was that the ship achieved 27 knots in the first sea sortie itself. Design speed is 28, so it was able to go up to the, almost achieve its full speed in the very first sortie. So it just goes to show about the quality of shipbuilding. All the naysayers who said that shipyard is building it for the first time, whether it work, not work, all that was put to rest. So I'll just take you through a few snapshots of the, to give you a sense of how the ship looks like. The hull fabrication, like I said, November 2006, when it actually started with indigenous steel. The keel was laid in February 2009 when Commodore Jitendran was there as the chairman. The launching happened in August 2013. Then a lot of this has come. This is Wärtsilä engines, 3 megawatt into 8. It can actually power up a small city. Probably, Navi Mumbai can be powered up by just the power that is available on the aircraft carrier. The switchboards, they all came from L&T Mumbai. Then the air conditioning plants from Kirloskar Pneumatics. The integrated bridge system from Navicon Mumbai. Of course, the aviation came from the Russians. So this basin trials were completed, and the compartments. Actually, the quality of compartments, I'm told, is a very high order. So that is it. I have finished my presentation. Thank you very much. And I'm sure in case there are any questions, you have two of the most eminent naval architects that the Navy has produced, and one of the finest shipbuilders, Commodore Jitendran, who can answer questions. But if there are any specific questions that you would like me to answer, I'm willing to take it on. Thank you very much.
Oh, thank you, Subbu. That was fantastic. I am sure the engineers who are watching this, especially the young ones, I hope they will also have big dreams of doing things which are beyond your dreams, like I will just add, I don't want to moderate anything. I think Harish and Subbu have covered beautifully the design, the challenges, the great determination, and the various solutions that were brought up to overcome challenges that happened during the construction stage. There was a few things that also contributed, I would say, to a large extent, to the transformation of the Cochin shipyard from a merchant shipbuilding shipyard to a shipyard which is now versatile and a world-class shipyard which can build almost any type of ship. Now, this transformation was actually required because when they got the order, as Subbu said, they always were used to getting orders which were frozen, like the design is frozen. And like many other shipyards in India, which, work on commercial basis, or you have a frozen design, or you purchase the kind of commercial design from abroad, you order the equipment as per the design, and then it's all a question of only building it up as per the design. Whereas here it is a concurrent issue. There was always a question what to do after the aircraft carrier. We cannot keep on building aircraft carriers only or depend on Navy. We need to be diversified. We need to be capable of so. So this capability issue was discussed a lot in the shipyard, not only in the director level, but also right down to the lowest workers level. And it was decided that we have to have several verticals going in the shipyard, both on the merchant ship as well as the naval construction ship, so that we grow as a diversified shipyard. Some basic, I would say, things were put in place during the decade 2000 to 2010, when this transformation took place. Some of them I'll tell you. One was, look, we cannot have lot of time wasted in approval of drawings. So at least on the commercial ship side, what happened was we asked the owners to come and approve the drawings on the computer. Now this saved a huge amount of time, because otherwise one had to write emails on the various design aspects and the procurement aspects with the owner. The owner will then send comments and it goes up, down, and a lot of time. So we had a situation where we had the owner's rep actually sitting in our design office and approving the drawings. This made a huge difference. The second difference, we said everything has to be done in 3D. And I must say that some of these designers in Cochin Shipyard, especially there was a lady who was designing hull. Her name is Anjana. Oh, amazing thing. They produced hull drawings in 3D, which I had never seen in my whole career till I actually produced them in Cochin Shipyard. And the workers were absolutely thrilled with it at the shop floor. This lady used to produce the 3D drawing and then go down to the shop floor and then ask the workers how it was. And then they used to produce exactly as for that. The accuracy levels reached phenomenal levels, the hull blocks. So that was the second. Look, we must do everything in 3D. Third was to get all the supporters ecosystem also on the same computer platform, so that you start integrating. It is not enough that you place an order for a pump or a valve, and then he supplies it, and then you come to know the weight and the volume of that later on. He has to supply this information at a fairly early stage, so that we know that it comes within the budget of the weight and volume. And this was another challenge. The fourth was accuracy and quality. So this, a lot of work was done where it was a diktat that everything must be done downhand. Subbu also explained to you this thing. So engine room deckhead being done downhand was unheard of in naval shipbuilding, in Indian shipbuilding in India, but it was done in Cochin Shipyard. That we will do everything downhand. If you can do the deckhead of an engine room downhand, then the quality is 9 out of 10 minimum. Whereas if you do it the normal way, that you do it, upwards like this, after the deck has been installed, then you will get only 5 out of 10. So this was also achieved. Another thing was the commercial aspects, that the payments for ships used to be made after the ships were delivered. So if there's a long time between launching and delivery, then we used to lose out a lot of money in the form of interest, because you cannot afford to have a ship more than 90 days if you use financial instrument after launching it. If it stays for more than 90 days in the shipyard, you had it. So another diktat was given. Look, if the ship is launching today, the chairman will come and see whether, and the director will come and see whether you are starting the generator on the same day or not. Now, if you have to start the generator on the day the ship is launched, 100 things have to be done beforehand. All the systems have to be proved, all the various things, all the hot work has to be completed. So this puts pressure on the planning and things. So many of these things were put in place, building blocks, I would say, which actually change the thinking as well as the ability of the shipyard, multiplied several fold during this period, because we had this challenge of the aircraft carrier to be done and completed, and also have other ships going. Of course, the shipyard got many other orders, including sophisticated ships from other agencies, because of this design capability and detail engineering, as well as the planning that goes into the engineering of the ship in a manner which the shortest possible time you can achieve the maximum output from the same facility. So I would say that a lot of credit goes to the grit and determination displayed by many officers and workmen of Cochin Shipyard, where they really put their best foot forward and came up with solutions, a phenomenal solution, which of course has stood them in good stead. They just were able to beat every other shipyard, including we could beat Koreans and Chinese when it came to quoting for ships and delivering on schedule. So Subbu was very much part of this journey during that transformation period. And we were able to bring this skill to the aircraft carrier. And finally, now the shipyard, which has got, I don't think they have a naval officer at the top level. They are able to do everything on their own. The way they brought home a fabulous ship, I must say. And I'm happy that there is a good design and engineering office in the shipyard for the future. I will end my moderation here. I over to Commander Bhaskar, who can take this forward from here, and to Commander Prasad.
Thank you, sir. That was a really, really, really uplifting talk from the moderator. He's already spoken about what Admiral Harish and the other personnel have been speaking about. And in this year of Azadi Ka Amrit Mahotsav, it is fantastic to see the change in processes that has been done whilst working on a huge project like this, the change in confidence which has come because of the involvement of each and every person. I won't just say the officers in naval headquarters, but personnel in DRD also, SAIL also, and in such varied different organizations. And most importantly, gentlemen, allow me to compliment you on change in thought. One of the most important things was, of course, the change in the military-industrial partnership, which was so beautifully brought out. The teamwork which has been there is also of a phenomenal nature. Now, the only thing that remains is for me to introduce Mr. V.C. Kamble, who's a former chairman of the Navi Mumbai Local Center, Belapur, and the honorary secretary.
Hey, Commander Prasad, we will take question answers before that.
Yes, sir.
Yeah, we will take.
The floor is open for some question and answers.
No, they are already there.
I have six questions over here. So from Mr. Jishnu S. Sharma, what were the major difficulties faced during the construction of the aircraft carrier? Does the Cochin shipyard capacity is sound enough for this production? I do believe, sir, that the talk that has been given to us by Commodore Karthik Subramaniam, as well as by Admiral Harish, has amply brought out this point, and then both of your questions have been answered. We also have a further statement saying, can we say that Indian aircraft carrier is a green ship, which I will pass on to Admiral Harish, please.
That's a very interesting question. I will say that there are a large number of green features in Vikrant. For example, the hydrodynamics of a ship need to be really optimal in order to make sure that you are not burning more fuel than it is required. So the whole ship model was tested at Marine, and it was optimized in order to make sure that we are not adding to the carbon footprint in terms of the fuel. It is also important to bring out that the ship complies to all MARPOL compliance requirements. In warships, we always use low sulfur high-speed diesel, which itself is very low polluting as compared to the commercial ships. Many of you must be aware of the IMO's new stipulations on emissions from commercial ships, both in terms of the fuel that they are going to use
We have sewage treatment plant on board, so all the effluents from the ship are treated before they are discharged into the water. We have ballast water treatment plants. So all in all, these are very important features which have been ingrained. So I will say that it's a combat platform with a lot of
Green features incorporated.
Thank you, sir. That was a very succinct answer and all encompassing at the same time. From Mr. Pankaj Bisht, we have also another question. Are we following what engineering standards were used? Are we following American standards such as ASME, ASTM, etc., or European standards or Russian standards? May I request Commodore Karthik Subramaniam, sir, to kindly take this up?
Yeah, see, commercial ships are built to commercial standard, but the aircraft carrier has been built to MIL standards and called the Naval Engineering Standards, NES. You see, these specifications which are drawn up by the Naval Headquarters and given to us, they actually meet NES or MIL standards, which is slight. In fact, I mentioned this in my talk. They are more stringent than what you get as commercial ASME or ASTM standards. So these are specific for warship design, and they are more stringent than commercially available standards.
With your permission, Commodore Jitendran, sir, if I could add to what Karthik Subramaniam sir has already said. Largely, what sir has said is correct, but there are also, for example, the steel itself has been built to NCD, which is our own Navy standard. The SAIL has built to these steel to these standards. We also have Directorate of Marine Engineering and their standards and EEDQ standards for the electrical appliances, which is issued by Directorate of Electrical Engineering at the Naval Headquarters. Apart from that, for the Russian AFC equipment, since it has to comply with the MiG-29K requirements, there are Russian standards which the Russians have used to evaluate all the parameters, design parameters, as well as construction tolerances which have been built in order to make sure that the performance requirements are fully met. Thank you.
Thank you, sir. We continue with a series of questions, and I have one here from Mr. Joe Joseph. After going through the questions, if you'll permit me, ladies and gentlemen, I'll just run through quickly. Is it true that employees of Cochin Shipyard put in great effort demanding big applause, but there is a general opinion going around that concept of aircraft carrier is obsolete? If it is obsolete, construction of aircraft carrier actually tied down the potential of efficient employees of Cochin Shipyard from constructing more useful ships like survey ships for vast unexplored ocean, cargo ships, etc. Well, sir, Mr. Tojo Joseph, as an ex-aircraft carrier man who's actually operated and worked on not one, but both our aircraft carriers, allow me to take this question. First and foremost, as far as the Cochin Shipyard is concerned, both the speakers have beautifully brought out as to how there has been changes in technology, changes in processes, and wherein each and every employee has given his best. So that is one positive which has come in. When you bring that positive into each and every one of your employees, it is a force multiplier. As far as the concept of an aircraft carrier is obsolete, well, sir, that also I have answered in my very first briefing when I spoke about the mere presence of an aircraft carrier during the Goa operations. Like I've told you, I live in Goa, and as well as the 1971 war. The question is it obsolete? It is not obsolete, and that is precisely the reason why today there are more than 17 aircraft carriers. I repeat, 17 aircraft carriers. China has got 3. One is under construction. The Queen Elizabeth II has been built just nothing less than 3 years ago. The USS Gerald Ford, the US and the other 11 aircraft carriers are very much there. The French Jean d'Arc is very much there. So the concept of an aircraft carrier is not obsolete. The amount of force projection which you can do for both offensive and defensive purposes from an aircraft carrier is something which you cannot get from any other platform whatsoever. Even if tomorrow you're using UAVs in place of your helicopters and your fighter aircraft, as well as EC through Hawkeyes, etc., even then it still remains an aircraft carrier. Question number 2. If the concept
Prasad,
of, so,
Commodore sir, moderator sir, can I add something to this? What Commander
please.
Prasad?
Yeah, please go ahead.
Yeah, this what MRDB and Institution of Engineer we are heading for. We want to create a positive mindset for this country, wonderful country called India or Bharat. We know, perhaps all the faculty and people here, they will agree. It was more easy to build a ship, and it was equally difficult to handle the pressure which is from outside. And there are wastage lobbies, wastage interest, which will come with all sort of these things with their wisdom. And what we got to do, we got to believe in the collective wisdom of country, and that is must for us for taking this country forward. Thank you.
we move on, ladies and gentlemen, and as far as I'm concerned,
With the permission of the moderator, may I add in a few small points, sir?
Yeah, please go ahead.
As Commander Prasad has said, sir has said, it is important for us to understand the requirements of national security from broader perspective. We are a growing economy, and most of our trade happens through sea. So it is important to guard our sea lanes of communication so that we can make sure that the reserves in wartime are available for our people. As we grow, it is very important that we have the capacity and capability not only to operate in shore or near the shore, but also away from the shore, because there are Malacca Straits, there are Gulf of Aden, large number of areas where we need to interject for SLOC, sea lanes of communications to be open. Thank you.
well, ladies and gentlemen, I've gone through the remainder questions. I do believe most of them have been answered. And as far as the participants and the moderator, etc., is concerned, we have got a number of not questions, but thanks for a wonderful webinar. This is one of the best which I've heard. And sincere salutations to the team is some of the questions which I can see over here. So without further ado, ladies and gentlemen, since we don't have any further questions and since all of them have been answered, I now move on to the next stage. That is I have the pleasure of introducing Mr. V.C. Kamble, who's the former chairman, Navi Mumbai Local Chapter Belapur and the honorary secretary of MSC Mumbai. He is an officer on special duty as chief engineer of Metro PIU at Mumbai Metropolitan Region Development Authority, that is MMRDA. And he has quite an illustrious career behind him. Shri V.C. Kamble is a BE Civil from 1972 and ME Environmental. He is retired as additional chief engineer from SIDCO Limited. He is presently holding the position of chief engineer for Metro Project at MMRDA, which I just told you about. During the last 39 years of experience in civil and environmental engineering, he's completed many housing and infrastructure projects, including the Metro Rail project. At the Institution of Engineers, he's held his position as honorary secretary from 2010 to 2012, and as chairman of the Belapur local chapter and council member for the period 2012-2014. He has been a convener for Environmental Engineering, Maharashtra State Center for 2018 to 21. He has held a position as member of ENDB, Technicians Chapter and Water Management Forum, and he has been nominated as an external examiner for the BTech and MTech courses at VGTI, Mumbai. May I now hand you over, ladies and gentlemen, to Mr. V.C. Kamble.
Thank you very much, Commander Prasadji. It's my great pleasure to be here, a part of this beautiful seminar on India's first indigenous aircraft carrier, the saga of great and technical transformations, which has been organized by our great friend, Commander Dr. Bhaskar Bhandarkar. He is a council member of the Institution of Engineers, India. Today's webinar, really, it was very good, and the galaxy of officers from the Navy and shipbuilding business are here to give highlights of the current topic and explain in and out of the shipbuilding, ship designing, and its functioning in the real life. First, I extend my sincere thanks on behalf of the Institution of Engineers to Commander M. Jitendran, VSM, and former CMD of Cochin Shipyard Limited. He has nicely explained the history of Vikram from mobilizing up to demobilizing. He moderated nicely and explained the zeal of the lecture given by two panelist members. So thank you very much, Commander M. Jitendran.
You're welcome.
Thank you, sir. Our next panelist is Rear Admiral G.K. Harish, retired VSM, former Director General Naval Design, Surface Ship Group. He has explained the design aspects, its drawbacks, advanced technologies, economics in shipbuilding, and he has given one narrative that consistency in policies, we have to maintain this consistency in policies. And he also nicely said the money needs to be flowed back to the country. So definitely he has explained how we are now depending on our technology, our expertise in building the shipbuilding indigenously. Also, the materials which is being manufactured within the India, and we don't have to depend on this import for the materials, imported materials. So thank you very much, Rear Admiral G.K. Harichi. Our next panelist is Commander Karthik Subramaniam, NM, former CMD, Cochin Shipyard Limited, Kochi. He has also nicely explained the procedure further to design of the ships and explain the procedure of construction of ships, its complexities, and all the technical challenges in shipbuilding. So thank you very much, Commander Karthik Subramaniam ji.
Thank you.
I sincerely thanks Commander Commander Prasad Padde ji. He has opened the webinar, introduced the audience about the theme for this today's webinar. He has nicely coordinated the entire proceedings of this webinar. So thank you very much, Commander Prasad Padde ji, for your beautiful, and also you have nicely explained the audience about their questions. Thank you very much.
So,
Today, our honorary president of the Institution of Engineers, due to he was very busy with this National Environmental Engineering Institute at Nagpur. He had meeting with the director Niri there. That's why he couldn't attend this webinar. So thank you very much for supporting to Dr. H.O. Thakre, President of the Institution of Engineers. Also, we express sincere thanks to Dr. G. Ranganathan. He is the chairman CATE, the Institution of He take care of all the technical activities of the institution. So thank you very much, Dr. G. Ranganathan ji. Also today, the session is open by the chairman of Navi Mumbai Local Center, is a Dr. K.M. Godbole. He is a acting chief engineer of SIDCO and handling many projects. He is a friend of mine. So thank you, Dr. K.M. Godbole, for welcoming all these dignitaries for this webinar.
Thank you,
And-
Comrade sir. Thank you. Thank you.
And the last person who is a man and brain behind this webinar, and he is conducting so many lectures in the small division of this marine engineering. He is none other than Commander Dr. Bhaskar Bhandarkar, the friend of all of us, not only mine, but his friend of all of us. And due to his nature and his ability to coordinate with all the people from the different background of this marine engineering division. So he's coordinating with this. He's asking, requesting all the people, experts, eminent personalities in the field, and making efforts to share this knowledge, to transfer this knowledge, dissipate this knowledge to the young budding engineers in the field. So thank you very much, Commander Dr. Bhaskar Bhandarkar ji.
Thank you.
Also, I express my sincere thanks is the person from this headquarter. He's coordinated the program. He is a Mr. Kingsuk from the headquarter. Thank you, Kingsuk ji. And all the members, if suppose by mistake I missed any name, the thank you to all the persons whose hands has contributed to make this webinar successful. And at the last, the audience, because we are taking lot many efforts to organize these beautiful lectures for the benefit of these professionals and young budding engineers also. So unless you are here, no program would have been successful. So thank you all the participants, delegates and audience for participating in this lecture. Thank you very much. Thank you very much. Thank you all. Jai Hind, Jai Institution.
Thank you.
Thank you, sir. Thank you,
Over
sir.
to Prasad Paddeji.
Well, sir, the vote of thanks is now over. We've had a wonderful session, which I'm sure all of us will be remembering for a long time. And any further questions on this, etc., can be directed towards the Institute. And please do remain in touch for further such mind enlightening inputs from the institutions. With this, man, we will all be leaving. Thank you all.
Yeah, before we finally part, I would like to announce that our next webinar is on 10 December, and the topic is Glorious Maritime Heritage of India. So gentlemen, do attend. Before that, we have 2 days All India seminar at Navi Mumbai on the water desalination and water treatment for mariners. And our huge and yearly event, that is Convention of Marine Engineering Division, will be held at NSTL Vishakhapatnam on 2nd and 3rd December. So gentlemen, do patronize, put your papers, and if possible, attend as a delegate. Thank you very much. Have a nice day.
Thank you, sir.
Thank you.
Thank you very much.
Thank you, sir. Commodore sir, Jitendra sir.
Thank you
Admiral.
very much. Thank
Thank
you.
you very much.
Thank you, Commander Bhaskar, Commander Prasad. Thank you very much. Thank you,
Thank
Dr.
you,
Godbole.
Yes, sir. Thank you. Thank you to all eminent personalities. They have made the good webinar session.
Thank you, Comrade sir.
Thank you, Bhandarkar sir.
Thank you. Thank you, Bhandarkar.
Thank you all. Thank you very much.
Right, we'll take leave. Thank you very much.
Okay.
Yes, sir.
Take leave.
Thank you.
Okay.
Good night. Thank you.
Bye.
Good night.